We restart the streaming. Okay. So today we will discuss about getter and reduce. Okay. So let's we start with getter first. So basically getter is opposite of scatter. If scatter is used to spread the data in array to many rank to all rank that are viable. So getter is like a collecting the data from other rank to one rank as a array. For example, if the rank that used for getter was rank 0, so rank 0 will have uh, array with number of member depend on the number of uh, the process available. So very useful for many parallel algorithms. For example, for a search to get a search result. So something like this. For example, we have a four rank from 0 to 3. So we have red, green, blue, and light blue. So if root was 0, so we have all the data from 0 to 3 as a one array in 0, something like that. So it's like pulling the data from yeah, positive the scatter to collect the data to the root process. So it's usable, for example, for uploading data or saving the data to the database because we shouldn't write the database using a parallel processing because that will make database connection is fluid. So it's better using a non-parallel to write to a database. Okay. So yeah, so it's use a buffer for its data to be received on the getter. So all structure have a receive count and receive data, but it's no longer used anymore. Maybe still used in some NumPy process, but it's not required anymore in new process. Okay, so let's we apply the getter in the programming to make it faster. Let's we use Jupyter Notebook on the Anaconda. Yeah, so let's we discuss about the very first programming using a file called getter simple. Here we go, getter simple. Yeah, getter simple. Yeah. Okay. The code is something like this. Let we restart the code. Okay. So for example, let's we use a most simple data called rank. It means each data will fill by each rank. For example, rank 0 will get 0, etc. And yeah, something like that. And the structure itself, same as broadcast, same as scatter, just data and roots because not rank by rank, but from all rank, all to all rank. So in broadcast or scatter, the parallel communication is processed between one root to all rank, but in getter, the process is opposite from all rank to the one root, something like that. So let me see what the result. For example, we start with 4, right? 4. Of course, we got data type. Okay, data type is a list, and we have 0, 1, 2, 3 because we have four process for from 0 to 4, right? Okay, so yeah, what if 8? Of course, we have 0 to 7. What if 32? Of course, we have 0 to 31, something like that. Okay. What if the data is array? Of course, you can rank multiplied by 10 or rank minus 10. Okay. So 3 with 3 1 structure 0, 0 minus 10 0 minus 9. So if the data is collect as data is array, it's same as scatter. It will be distribute as array. So in this scatter process, the data itself can get multiple dimension of array. Okay, yeah. So actually, um, there is a all example about getter numpy. It have a mysterious result. So, no, 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 not this one, but all in all. Okay. So I think we don't need to discuss about all in all. I have discussed it uh, on the class B, but it have a bad result, and that's not will be in the midterm uh, exam. Don't worry. Okay. So only thing that we have discussed that will be shown on midterm exam. Don't worry. Okay. Yeah. Uh, okay. So what if we want to use a numpy? I don't know. Uh, yeah, you can search on YouTube how to rightly pronounce. It same like GTX TI, TI, TI or TI, something. Okay, NVIDIA. Okay, yeah, so we don't need to discuss about this, right? Okay, maybe if you forgot, NumPy is a matrix library for Python. So, yeah. uh, So what is the type? The type is used to initialize the um, data type of the NumPy. So it's plus rank. It's mean 10 0 0 is mean then NumPy dot zero. It will create the array with 10 digits of zero. And it's plus rank. It means each member of the matrix will add by rank. So that's why it's will be something like this: 0, 0, 0, 0, 1, 1, 1, 1, 0 plus 0 equal 0, right? Okay. Okay. So it's a send buff and receive buff. Okay, that's what we discussed in this slide, right? So we can define the receive buffer in there. Okay, so we need to define the same structure. So zeros is like null or a zero for a dedicated number of array. So it's same as C++. Like for example, you want to define an array of integer, you must define send buff and receive buff is equal to 0. So we need to define the receive buff, same as the structure of the each rank. So yeah, we need to something like that. So if you set this as a f or float, there will be a float. String is will be a string, something like that. I will discuss it later. So there was a question in the class B. What different between between D type and as type? As type D type is used as the parameter input parameter of the functions or the array. Any function of the NumPy that used to create a new NumPy NDRI. The type is parameter input, but as type is a function. Functions that are available as attribute or object of NDRI. So you can convert the data on the each every data on the numpy array to any specific. For example, it should be integer, right? Uh, So the default is integer. So for example, integer. Oh, sorry, int, int, not integer. Okay, so as you see, there's no point in Indonesia called comma. Yeah. So, but if we send convert it as float, that will be a float. There's a comma between there. Yeah, float. So it's convert to float. Yeah. So this is the result. If you use 8, will be 0 to 7. And of course, if we convert this to F, you need to convert this to F also. So all attribute will be a float, something like that. Okay, yeah. So what is the assert? So it's to uh, close the all receive buff in there. So this is the template to the do getter in NumPy format. So, actually, you don't need to do this. You can define a NumPy array in there, but this one maybe have more efficiency on the structure, data structure, on the data structure and memory size maybe. But I think there more process. Uh, Maybe no, because in there maybe if you use a NumPy, there is a lot of sub process that unwritten in the script but happen. Uh, but in this process, actually just uh, what written on the script is happen. So longer script doesn't usually means there is a less resource that used. So let's we move to the altogether. Maybe it's enough. We don't need to discuss about all to all. If you're curious about all to all, you can yeah find the video in class B. So altogether is very simple. Very simple. I think we that doesn't even need to discuss about this. Alligator is simple. It's same as yeah, broadcast maybe broadcast, but in broadcast every rank will receive the same data. In Getter, yeah, every rank will receive the same data also, but the data itself come from the combination of each rank. So yeah, um, it will be the question for the midterm exam. What the parameter of alligator? If alligator, there is no root. There is no root because everyone is root. Everyone is root. So everyone get the same data. You get the whole data. You get the whole data. You all get the whole data. You know that. Okay, that's what means. Okay. Yeah. All to all, yeah, it's still mysterious. I didn't have tried it on the Google Colab, but some mysterious happen in there. Yeah, and yeah, let's we don't waste our time to discuss about this. Okay, if you have a question, you can ask in WhatsApp group or something. Yeah. So let me move to the reduce. Okay, yeah. So we talk about reduce. Reduce is same as getter, but instead of collecting data as array, we process the data in a function. Yeah, function like that. That's called reduce. Actually, we will discuss about map and reduce in the topic after midterm using a PySpark. So actually, reduce is the last time you will see MPI in this subject. Okay, para processing. Last year it wasn't. It wasn't. We were still using MPI till the end, but yeah, we decided to use a PySpark after after midterm because it also parallel processing. Yeah. Yeah, processing. Alright, so it's simple. So, structure is same. Data and root. And all data will be go to root, not from root to all, but they will process. For example, max, min, sum, prod. So, for example, the graphic will be something like this. Yeah, let's make it simple. Simple. I think graphic is easier to describe than text. So some, some, right? It's like editing all member. So five add two, seven, right? Seven plus seven, 40, and plus four, 18. Yeah, you're smart. Then fifth grader. It also can happen with alright, 18, 3, 1, 3, 4, or 12, 40. Okay, something like that. That's some. Okay, so result of the reduce instead of uh, array is will be single number with max, min, sum, prod, or something. It even can do a logic. It will have true or false result. Yeah, something like that. So what what is true and false in integer? So if the number is not zero, that will be true. And if zero is false. And if there's a zero in the one of the rank, for example, rank zero, the width will false, right? But in OR, except rank 0 is larger than 0, so it will be result true, something like that. Yeah, the structure is something like that. Sorry, we skip the slide to make it more efficient in my brain. Okay, something like that. Data process. You can use it as a note if you forgot. But I think it's easy to remember, right? It's actually same. But operation is you can use uh, new function or a dedicated function. So there's also log. It will return the um, first of member of array if the multiple array. So we will know the ID or location of the data. Okay. Alright, this I think we don't need to discuss about this deeply because it's simple. Simple. You get the you get the reduced result. You get the reduced result. You all get the reduced result. Okay. So you are not the one to get the result, but everyone get the result. Okay. Simple, right? Simple, right? Of course, it's there's no root in there because everyone is root. Okay. Yeah. Yeah, yeah. I always think it's easier to talk to the computer than talk to a human. Okay, yeah, that's joke, joke. Okay. Yeah. So let's be use which one? Redus, where are you? Oh, here. So let's we start with what the first code. Redus. Okay. I almost search for Redux simple. There's no Redux simple, just Redux. Just Redux. But we also open a Redux logic. Redux array, Redux function. We don't discuss about Redux scatter because it's confusing. Of course, we have all Redux. Okay, let's we start with Redux. Okay, so yeah, so that data equal oh, well, plus one. So yeah, it mean there's no zero, just one. So let's make it zero. So there should be false. Okay. So this MPI sum means okay prod all is multiplied. It's from the max log and min log is data 2 because data 2 is should be multi two array it will return the location. So I thought it will return the rank number automatically, but actually not. The input of max log and min log should be array with two member. First one will be the log or index, and the next one will be the thing that we compare in the max or mint. Okay. Yeah, this is bonus. This is bonus. This will be return the average or means. Simple. Average itself just divide the sum with the com size. Okay. So let me see the results. Okay. Yeah. Six. Sum six. Okay. One zero plus one. Zero plus one is six. Mean is 1.5. Yeah. So six divide using four. 1.5. 5. Minimum is 0, maximum is 3. Okay, prot 0. So it will return F2. So it's used it like your student ID, right? Student ID. So 3 means you can add any number in there or simply to com.rank, but I want to make a fun. It could be a string also. So it's depend on rank. So actually this is rank 3. Rank 3 will have a 4, something like that. Because there's still rank plus 1. Okay. If we delete the plus 1, it maybe make you simpler to understand. Yeah, 3 is 3, 0 is 0, something like that. That's difference between minimum and maximum max log and min log. Okay. So yeah, what if we want to do this on array? Like, like that. So yeah, data is called append, range com size append. So it will be uh something like uh yeah, in range data dot append com dot rank. So it will be make a multidimensional array with if the number of process is 4, there will be 0, 0, 0, 0, 1, 1, 1, 1, something like that, because all data that appended is rank itself, right? So yeah, if 8, so 0 8 time, 1 8 time, etc. Okay, something like that. So we can sum, min, max, something like that. So it's something that shouldn't happen. It's happened. So it's not actually summarize the result, but just uh, appended the list. So don't worry, we make dedicated function in the bottom. Okay, yeah. So minimum is so they can search for the minimum in array and maximum array. So let's we do the logic. The logic, where are you? Like here. So logic, the data is something like this. Yeah, around com dot size is mean if the data is 4, then divide using 2 will we have a 2. But if the rank size is 5, it will be 2.5. So it will round to the 3, something like that. So it makes sure the data is larger than the half of the rank size. So we can compare it using float. So we use round to make it integer. Okay. So, for example, yeah, if the yeah, you will see the result. Don't worry. If the number of process is 4, there will be 0 and 1 and 2 are false, but 3 are true because it's larger than. So 2 is not larger than 2, but it's equal. So it's still false. Okay, like that. And or uh, bitwise and so let's see the result. Uh, So 3 is true, 1, 2, false, and n is false, also false, or it's true. Because if one of the rank is true, so the result will be true also. Okay, something like that. So next is already, yeah, we don't need to discuss about it. Okay, simple. Everyone get the results. Okay, MPI dot sum. Yeah, everyone gets six. Everyone gets six. Okay, only one that gets six, but there everyone gets six. Something like that. So, yeah. What if? What if? We want to. We want to make a or original or a new function. Okay, a new function. So I want to make a functions, my own functions. How to? So this is wrong one. This is wrong one. So input of the reduce is not list, but the concept of A and B that used in function to reduce and concept of lambda. Okay. So the logic is something like this. For example, list is 0 to 4, right? So you can use a reduce in there. It's not MPI. It's just a single for reduce, not parallel reduce, series reduce. So you can use a concept of lambda. Lambda is if the function itself is too short, something like that. You don't need to make a function, but just use a lambda. Now in lambda, the structure is in between 2 point. Yeah. Before this is a input parameter, and after this the function. So concept of the lambda reduce is in list. So how it works? For example, first A is one, then B is two. Okay, then A plus B become three, right? So A become a three. A become a three. So will be replaced by the calculation or process result. Then B will replace by a next member, which is a three, right? So 3 plus 3, 6, 6 plus. So the A become a 6 and B become a 4. Then final result is 6. The 10. Okay, 10. But it's multiplied by 10. Okay, like that. So something like this. You understand, right? We start with 1 until 5. So the result will be 10. Okay. Why that was six? Six because it start from zero. Uh, it's 10 because same like this. Start with one. Okay. So what if we want to make our new functions, not the lambda one? So simple. We just create the functions a and b, and a plus b multiplied by 10. So it's not will be 100 is different. So it's like 1 plus 2, 1 plus 2, then the result will be third, uh, 1 plus 2, 30, and next one is 30 plus 3, 33 will be 300, 330, something like that. Yeah, etc. So the result would be relatively large. Yeah, three three 3,340, something like that. Yeah. it's similar as the series of Intel i5, i5 or i7, i7 337, third generation. Okay, something like that. So let's we look for a reduce function. Reduce function. Okay, so yeah, let's we make a complicated data with three-dimensional array, and let's we make a um, real array sum. Yes, a plus a0 plus b0, a1 plus a1, and etc. So it's a rank 3 and yes, multiply by 3, multiply by 10. Let's see the result. So result is at 1080. So maybe use the confusing. Let's we change the data to 10, 100. Yeah. It yeah. Okay. So something like that. Will be rank, so like 40, so like that. I forgot there's a still rank. So something like that. It's actually just three. Okay. Yeah, something like that. So, what if input is three, uh array with three member and output is three. What happen if the output is for example we make a random something random like this. Okay. Uh, can it happen? Of course, happen. It's our own function, so there's no limitation, right? Something like that. So we can make a very advanced function in there that maybe use in algorithm or something. Okay, that's all for the class A. Don't forget the exam for the class A also written in English. Actually, I use a translator for faster result, but don't worry, I reread the question to make sure the translation result is understandable. Okay. Okay, that's all. I think no one watch it live, but yeah, thank you. So maybe you can watch it later. So see you in